Bagi memberkati majlis pada malam ini, terlebih dahulu, marilah sama-sama kita membaca Ummul Kitab Al-Fatihah. Amin, amin, ya Rabbal Alamin. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera dan selamat malam. Yang dialu-alukan Prof. Madya Dr. Karimah Kasim, pensyarah UiTM, yang berusaha Dr. Aisyah Muhammad Sharif, pengarah program Eksplorasi Instrumen STEM, serta yang dihormati hadirin hadirat yang hadir dalam secara langsung Facebook dan YouTube pada malam ini. Selamat datang saya ucapkan ke program Eksplorasi Instrumen STEM siri ke-37 dengan topiknya pada malam ini ialah The Beauty of Imines. Bersyukur kehadrat Allah kerana dengan izinnya dapat kita berkumpul program ini walaupun secara dalam talian. Saya yakin para penonton sebelum saya menyerahkan program kita kepada speaker jemputan, terlebih dahulu saya ingin form kehadiran dengan mengimbas QR code yang akan dipaparkan di skrin. Dan anda diingatkan untuk mengisi setiap maklumat dalam Google Form tersebut dengan tepat untuk memudahkan urusan penghantaran E-sijil. Okey, jadi anda diberi masa selama 1 minit untuk scan QR code terlebih dahulu. Sekiranya anda menghadapi sebarang masalah untuk scan, anda juga boleh klik pada pautan yang ada dipinkan di ruangan komen Facebook ataupun YouTube. Baiklah, kepada hadirin hadirat yang mungkin baru join program live kita pada malam ini yang mana tidak sempat untuk mengimbas QR code kehadiran, anda juga boleh klik pada pautan yang ada dipinkan di ruangan komen Facebook dan juga YouTube untuk mengisi Google Form sebagai bukti kehadiran anda. Hadirin yang dihormati sekalian, untuk pengetahuan anda, Google Form tersebut akan dibuka sehingga jam 9.15 malam sahaja. Jadi tanpa melengahkan masa lagi, majlis dengan sukacitanya menjemput dan mempersilakan speaker jemputan kita iaitu Prof. Madya Dr. Karimah Kasim untuk menyampaikan perkongsian beliau pada malam ini. Dengan segala hormatnya mempersilakan.
Okey, Assalamualaikum. Terima kasih Cik Nazlin Alia atas pengenalan tadi. Okey, sebelum saya mulakan, allow me to speak in dual languages. Okey, Assalamualaikum, selamat malam. Saya Associate Professor Dr. Karimah Kasim daripada UiTM Shah Alam. So my talk today will be on the beauty of Imines. Okay, before I proceed, let me introduce. I think some of you have heard of UiTM. So this is where I come from. UiTM has a few COE, Center of Excellence. So I am from Institute of Science. Okay, Institute of Science was established in 2004 and we are mainly focusing about research. Okay, here in iOS, I would say we have 3 centers. Okay, centers for chemical synthesis and polymer technology, Center for Functional Materials and Nanotechnology, and also lastly would be Center for Astrophysics and also Radiation. Okay, last week we had our colleagues, Dr. Nafhatun, have shared her research findings. She is from the Astrophysics. Okay, these are my teammates actually. We have Associate Professor Dr. Fazli, I myself, and also Dr. Nur Hidayah. And we have fellow honorary researcher, Prof. Dr. Ahmad Sazali Hamzah, Prof. Dr. Zurina, and also Dr. Nurhana. Okay, basically all of us are chemists and biologists. Okay, before I proceed with my sharing, so we have a pre-quiz session. So you have 1 minute to try out the quiz. Okay, ada 1 minit untuk cuba menjawab quiz yang related to my talk today. Okay, time's up. Okay, so basically what is E means? Why do I say it's beauty? Why do I say it's beautiful? Okay, E means basically is a functional group of organic compound. So it contains carbon double bond nitrogen bond, C double bond N. So maybe some of you have heard of alcohol, amines, amide, thiosulfate. So this is one of the subcategories of group in chemistry in organic synthesis. So we have imines, C double bond N. So this is also known as azometine or also sheaf-based ligand. Okay, so why imine is very interesting because it has a very strong attractions towards metal. If you can have a look at this structure, it has N nitrogen which is acting as a very good donor atom. That means dia ada lone pair dekat atas nitrogen kat sini. So you have your R1, R2 and 3 are all the functional groups. Okay, E means azometine or sheaf bases is all these are the same. They are C double bond N is named after an Italian scientist named Hugo Schiff. Okay, was back in 19th century. So he found a sheaf base after a condensation compound between aldehyde and ketone. So I'm sure you have learned your chemistry before this. So aldehyde you have C double bond O and H. Kalau ketone you just change your H to CH3 methyl group. Okay, so whenever you have C double bond OH from aldehyde reacted with a primary amine NH2. Okay, so this is what we call a condensation reaction. So we produce a hydrolysis of water. They can remove water as a byproduct. And you get the new bond here, C double bond N. So this is what we call sheaf base or imine or azometine. Okay, so this is very general equations of producing sheaf bases. So why is it important? So this is very common ligand in coordination chemistry. Yes, I said before, ligands, that means it must have a donor atom. So here, the specialty of sheaf base is your nitrogen acting as a donor atom. So we also have a pi acceptor here because of the conjugation system. So bila cakap conjugation system, that means it must have a alternate double bond. So this can be derived from alkyl diamines and also any aromatic aldehydes of ketone. Okay, kalau you have a look at this structure, the first structure, the couple complexes of ligand derived from salicyldosmine, this is actually similar to a macrocyclic compounds which is also similar to your hemoglobin structure. Okay, your red blood cell structure, hemoglobin, except that kalau hemoglobin, you akan change your copper to iron. Okay, this is also what we call saline, a tetradentate ligand. So kalau tengok kat sini, we have two nitrogen. So this nitrogen has very good potential to form complexes towards metal. Okay, and the last compound is your Jacobson's catalyst. So this is a very good catalyst, mostly used in industry. So this is also derived from your saline ligand. So how do we synthesize sheet base? Okay, we have two methods. Kalau ikut conventional methods, is actually a reflux conventional method. So these are the setup. This is the setups of conventional reflux method, whereby you have a round bottom flask and connected to a condenser. Okay, so you immerse in an oil bath because this would take between 6 to 7 hours. Okay, so these methods have been used since many years back. Okay, so nowadays with the technologies, we have come up with a microwave assisted method, we call this. So when we talk about microwave, many of you maybe imagine your domestic microwave, the one that you have in your kitchen, right? So unfortunately, this is not the one that we use in our lab. So this is how a microwave assisted method atau microwave assisted instruments that we use in our lab. Right? Okay, to have a clearer picture, okay, this is a conventional reflux method. So we have a hot plate instead of oil bath. We use a solid ataupun metal solid to control the temperature. And you immerse your flask in a solid block and connect it to a reflux condenser. Okay, as I mentioned before, this will take up to 6 to 12 hours for one reaction to occur. But in microwave, you only take minimum, maybe perhaps like 10 to 15 minutes to perform a reaction. So this is a very advanced technology. Okay. So how does a microwave works? So you put your mixture, you place your mixture in a vial. For example, in conventional methods, you place your compound in a vial, so you will start heating. So heating will only occur on the surface. Okay, bila heating on the surface and it slowly comes to the whole amounts of your solvent, then only you can have a kinetic reaction. So this will take some time. But in microwave, your heating, you introduce heating to all over of the molecules in your solution. You also introduce a high pressure with minimum amount of solvent. So this is what we call a green synthesis, because you will use only a very minimum amount of solvent. So here you have a rapid and uniform heating, a shorter reaction time, and producing a very high yield. That means amount of product produced is very high compared to your conventional method. Okay, so again, this is also known as the green synthesis method. Okay, let me show you examples of product using conventional and also microwave here. So we have synthesized a salicylazine. Okay, back in 2017, proposed by Lugacy, the German scientist, proposed a two-step reaction, a two-step synthesis reaction. So the first step reactions take up to 12 hours and also another 2 hours of reflux, right? So the only the product that he gained is only 67%, right? But in our lab, my students only synthesize salicylazine using only one-step reaction. So here, the reactions only took place for 5 minutes in 80% of ethanol and producing 85% of yield. So here we can conclude that with technology, we can produce a faster compound, a shorter reaction time, and also a high percent yield. So if you can see here, this is the structures of imine. We have C double bond N here. So you have produced a very good product of salicylate and zinc. Okay, what do we do when once we obtain our product? So once you obtain a product of imine, we have to characterize. We have to confirm the structures that we synthesize. So how do we characterize? Okay, the first instruments that we use is microelemental analysis. Okay, this is what we call CHNS analyzer, the model of thermoflash EA. Okay, basically this is to determine the percentage of carbon, hydrogen, nitrogen, sulfur, and also oxygen in the compound. Okay, for example, you have these two compounds of imine. Okay, you have C double bond N. So you have to calculate the amounts ataupun the numbers of carbon, hydrogen, nitrogen in the structure, and you predict how many percent of weight for each of these elements. Okay, so you have a compounds, you weigh your compounds between 3 to 5 milligrams. So we have here a very small, tiny microbalance because this is a microanalysis. So you will insert into an auto-sampler here. So your compounds will be combust. Okay, so we have a GC column inside here. So this GC column will separate your compounds. So you have a results of percentage for each element. Your carbon, hydrogen, and nitrogen, oxygen, sulfur, and so on. Okay, so this will confirm whether your compounds has been successfully synthesized or the other way around. Okay, and the process will take only like 12 minutes. So this is only a very fast analysis for the CHNS analysis. So next would be on the FTIR spectroscopy. I'm sure this is very common to some of you. So what do we do in FTIR? So here for spectroscopy infrared, we have to identify the functional group. The fingerprint for functional group given here, if you can see here, for your C double bond N is between 1600. We also have other functional groups, for example, your C double bond S, your thiol, your carbonyl, that means above 1600. Your NH peak is between 32,000. Okay, so this is a tool to allocate the vibrate frequency to confirm the functional group. Because in IR, dia akan ada vibration. So vibrations, so dia akan record here as in wave number. So how do we prepare samples for IR? So there are actually few methods used. So one of it is using KBR palette. So you have to mount your samples into KBR palette and you insert in a holder. You passes through your IR wave, so it will appear as a spectrum here. Okay. Other than KBR, we can also use ATR method. Okay, whereby it's a very direct, it's the easiest method. You can just pour your samples ataupun you can just place your samples on top of ATR holder, and you can also straight away run your IR light, IR beam actually. Okay. So this is your infrared spectroscopy. Okay, so we have confirmed previously functional group, numbers of carbon, hydrogen, nitrogen. So here we have next instrument what we call UV spectroscopy. Okay, so this is your UV spectroscopy. So the functions of UVVs is to determine the chromophores of your C double bond N, C double bond C, CO, all the functional groups. Okay, how do we confirm that? So here, if you have look here, the spectrums contain absorbance and also wave number in the UV region. UV region is between 200 to 700 nanometer. Okay. So when we're talking about double bond here, obviously you have a pi bond. So this pi bond will excite to a certain wave number, so it will be recorded as absorbent. Right? So kalau you tengok kat sini, you have two structures here, you have lots of conjugation. Conjugation, that means you have double bond. You have double bond O, double bond N, aromatic with cyclic double bond, and so on. So you will observe like peaks here between 200 to 300 nanometers for pi star. Means from bonding to anti-bonding, level of chromophore C double bond N. So this represents your imine. Okay, so how do we perform your UV? Okay, UV you have a small cuvette. Cuvette maknanya ada holder kat situ. Your compound as in solutions will be placed in a cuvette. Okay, so you insert your cuvette in your UV holder and you pass it through your UV light. So the electron ataupun the electron when you absorb the UV light, they can excite to a higher level, a certain wave number. So will be recorded as absorbent, right? So okay. Next instrument. This is considered a powerful instrument as well, a proton and carbon-13 nuclear magnetic resonance spectroscopy. So this is what we call NMR, nuclear magnetic resonance. So this use a large magnetic probe. That means you will use a magnet inside to produce magnetic wave. So you will insert your compound, the solutions on top of this instrument. Okay, they can pass through a chamber. So here you have a magnetic wave here. Okay, when you start a wave at certain wave number, so this proton, when we talk about proton, that means your hydrogens will vibrate. Okay, they can vibrate, they can record as in spectroscopy. So here you can see a few peaks. So this peak will represent each proton in your compound. Kalau you buat proton NMR lah, proton that means your hydrogen, one here. Okay, kalau for carbon-13, dia akan record as in carbon-13 nuclei. Okay, so how do we prepare your compound? Again, your compound will be dissolved in deuterated solvent. It mesti ada special solvent for NMR. They cannot use any solvent that you can get from your benchtop. Okay, solvent that we use normally is deuterated chloroform, deuterated DMSO, or deuterated acetone. When I talk about deuterated, maknanya dia use isotope of D, not H hydrogen. Sebab kita tak nak the hydrogen in that solvent will disturb the reading. Okay. Right. And next we'll use X-ray. This is also considered advanced technique in characterization if you obtain a single crystal. Okay. So maknanya kalau you manage to get a crystal, your structure is like 90% confirmed. Good. So this is a non-destructive tools to analyze your compound. Because here dia macam X-ray lah. Bila kita kat single X-ray, dia macam X-ray. So dia akan ada X-ray beam passes through your solid, your crystal. So dia akan bagi information. Dia akan bagi crystal system sama ada monoclinic, triclinic. Dia bagi space group. Dia bagi unit, berapa unit cell, berapa dia punya bond angle. For example, here you have 90 degree, 127 and also 90 degree alpha, beta, gamma. And also, dia akan bagi very detail of bond length and also bond angle for each of these attachment. Okay. So you will have a bond length in a unit of Armstrong because this is a very nano size compound. Okay. So we have here X-ray in UITM. So this is from Brooker. Okay, so to analyze a crystal, a single crystal would take like 12 to 24 hours. Okay, so kita dah synthesize, kita dah identify, kita dah characterize compound tu. So what is the use of this compound? So these compounds have a very wide range of applications. Okay, basically these are the three applications that we do. First of all is your bioactivity. Secondly, as corrosion inhibitor, and lastly as catalyst. I will explain details later. So for your applications as corrosion inhibitor. Okay, kita tahu kalau industri, they have major problems especially in acid pickling, petroleum, medical devices. So corrosion is going to become a very big issue. So these compounds have anchoring points. So it will inhibit, that means they akan protect your materials from corrode. So to study your corrosion atau potentials of corrosion inhibitor, we use an autolab. So here from the autolab, kita akan tengok the percentage of inhibition. If it has more than 80%, that means it will become a good potential corrosion inhibitor. For example, here ligand 1, you have 82.2%. So it shows that the compound can become a good corrosion inhibitor. Okay, so how does it perform? So kalau tengok tadi kat sini is your C double bond N, your imine ada donor atom. So this donor atom will be protected ataupun will be donated on top of your MyCAT. So dia akan buat coat, dia akan cover your material. Okay, so we also studies on the homo-lumo of the structures using computational studies. So this will give extra details atau explanation on how is the performance of a compounds towards MyCAT. Right. Oh, okay. We have come to a session for lucky draw. Nanti organizer will run a wheel of names. Let's see who's the lucky person today. Okay, tahniah pemenang dia. Pemenang yang bertuah Nur Solehah Amira binti Muhammad Zain. Tahniah. Okay, pemenang bertuah yang kedua. Syariani Yasin. Tahniah saudari Syariani Yasin. Alright, we continue with my sharing. Okay, tadi kita dah tengok potential for shear bases. The first one as corrosion inhibitor tadi. Kita tahu corrosion inhibitor dia akan deposit on top of MyCAT, dia akan protect your compound. Okay, so why it means very good protection because it has a donor atom for nitrogen. Okay, another example is as antibacterial. Okay, these compounds can also be used in biological system, right? So here, you can have two possible applications. One as corrosion. Kalau tengok sini, we have calculated your compound using Lamware isotherms, using the instrument that we call just now, autolab. So in antibacterial studies, we use MIC method, a quantitative method. Here kat sini kita akan pakai plate. We tested on different kinds of bacteria. Kita ada gram positive bacteria, kita ada gram negative bacteria. For example, we have E. coli, Staphylococcus, Staph aureus. For those who are doing biology, may be familiar with this. Okay, ada two methods actually we use, distributions and also MIC. So this shows that these compounds have very good potential to kill the bacteria. I would say to kill the bacteria, okay? So nowadays kita tahu antibiotics because all the virus, all the bacteria dah almost potent with current antibiotics. So the needs to find a new set of antibiotics is very crucial. So if you have looked at this bar chart, the compounds that synthesized in our lab have very good potential ataupun at par with the standard antibiotic use. But this is still at preliminary studies. clinical studies must be done to proceed from here. Okay. Okay. There's another set of compounds. So this is this diffusion method. Kalau tengok sini ada plate dekat sini, a petri dish. Diletakkan agar, broth agar, and then we place your bacteria. Then kita letak a few division dekat sini. Kita akan divide and we place a small dish. This dish will be immersed into your synthesis compound of imine. Kita celupkan dia, kita akan letak atas agar ni. So here kita akan buat observation between 24 to 72 hours. Right? So this shows that this complex inhibit better compared to your ligand. That means kalau ada complexes, for example, compound tadi dia synthesize guna copper, iron, cobalt. So these cobalts ataupun these metals will have a better inhibition compared to your free ligand. Okay. Why? Because this will increase the lipophilicity of your compounds. Dia akan penetrate your bacteria cell wall. So dia akan penetrate, bila dia penetrate, this will kill your nuclei of your bacteria. Okay. Alright. So we can also use this compound as a catalyst. Okay, definition of catalyst is to speed up your reaction. So catalyst mostly used in industry. Okay, so the catalyst reactions mainly that we focusing is Suzuki and Head reaction. So kalau kat sini kita ada homogeneous and also heterogeneous catalyst. So instruments that we use here is strictly kerosol. Dia macam kerosol, dia ada banyak tube. I'm sorry, I don't have the pictures right here. So kita akan masukkan compound and also catalyst. Then we investigate using different parameters, basically your bases, your solvent, temperatures and also catalyst loading. Okay, so how do we check here bila ada reaction, for example, your head reaction. Your head reactions convert from double bond to a single bond. Kita pakai compound. So we will confirm that using GC, gas chromatography, and also NMR. Okay. For heterogeneous catalyst, kita akan pakai different functionalized material. And we also will studies on the surface analysis. Kita akan tengok SAM, kita akan tengok EDX, and also kinetics, isotherm, and also thermal analysis. Okay, these are the structures of the synthesis compound. Kalau tengok kat sini macam ball and stick structures. Okay, this is actually your structures obtained from the X-ray. X-ray yang I've mentioned earlier. Kalau kenapa dia macam berselerak. So don't worry, this is not selerak. Maknanya kalau compound ni dia macam flakes, dia ada overlapping of different particles. That means dia akan dapat one big lump of structure. Okay. Alright. This is also some of the instruments ataupun I would say alat-alat yang kita guna dalam lab. I think this is very basic instruments. We have rotovap here. Rotary evaporator. So once you synthesize a compound, you nak remove solvent, kita akan pakai rotovap. Dia akan suck all the solvent, excess solvent akan tinggal solid. Okay. So the second instrument we have here is a melting point. Okay, it's very crucial to determine the melting point when you have synthesized compound. So melting point is also one of the methods to justify whether your compound is pure. Kalau dia punya melting range is very high, that means ada impurity. That means kalau melting point range dia, for example, you have between 150 to 152, we can consider that as a pure compound because it will melt very fast. Okay, so how do we use here? We have to insert your compound into a very small capillary tube. So bila ada capillary tube, dia akan masuk dalam heating bulb here. So we will observe, dia akan automatically keluar dia range number. Right. So next here we have what we call a GUI balance. Okay, what is GUI balance actually? This is what we call a magnetic susceptibility balance. Bila saya cakap tadi, she-based imine complexation, we talk about complex metal. Metal kita ada various of oxidation state. For example, you can have iron 2, iron 3, cobalt 2, cobalt 3. Okay? Ataupun apa lagi? Copper 2, copper 3, nickel 2 and nickel 3. Maknanya ada nickel 2 plus, nickel 3 plus. How do we determine compound yang you dapat tu sebenarnya nickel 2 ke nickel 3? So this is the functions of your GUI balance. You akan masuk your compound into a balance. Dia memang balance kat dalam ni. Ada magnet. So dalam magnet tu nanti bila you insert the weight of your compound and also the measurement height of your compound, dia akan measure automatically to give a certain reading. So this reading will be converted to Bohr magneton. Sebab bila Pak cakap pasal magnet, unit for magnet is Bohr magneton. Okay. So this magnet will be weigh and also give you some sort of value. So dia akan determine whether your compound is paramagnetic or diamagnetic. Also predict whether your compound is high spin or low spin. So this is very sensitive instrument sebab dia punya balance kat sini very sensitive kat sini. Dia tak boleh ada some sort of interference of air ataupun noise. Okay. Okay, let me introduce to my lab. Quite messy lab tapi kat sini lah banyak produk yang dihasilkan. So this is the workbench of my students. Right, so our lab is located at the 3rd floor of bangunan sarjana. So we have actually 3 fume hoods here and also 1 chemical store. Right, so you're all welcome to visit our lab whenever you have you be whereby in UITM. Alright, so we have come to the end. Ini ada post quiz. So I hope you all understand ataupun very clear with my explanation. So I give you 1 minute to answer the post quiz.
Doktor. Bukan
Oh,
mic.
sorry. Okay, again I repeat ya. So job opportunity for this area basically in science, I would say science, because I'm sure all of us here sekarang ni will have a very strong science background. So bila cakap pasal science ataupun chemistry, ramai I'm sure semua dah pernah buat eksperimen, akan conduct analytical qualitative experiment. So bila you conduct experiment, basically you will have a very good analytical thinking. Mesti macam nak tahu kenapa compound ni jadi macam ni, kenapa masalah dia jadi macam ni. Alright. So a good scientist, I would say a good science student, okay, boleh venture apa-apa pun job scope actually. Okay. So one of it is as science officer. Right. So science officer maknanya dia in charge of it can be in charge of instrument, charge of lab, right? And other than that becomes a researcher. Researcher, you can either be a chemist, a biologist, even a forensic scientist, right? So forensic scientist pun interesting juga sebenarnya. Dia macam kalau you tengok cerita CSI kan. So it's a combination of a chemist and also you have a little bit knowledge of law, right? Okay, you can also become a product specialist. When I say product specialist, that means you deal with a very high-end instrument. Okay, in my talk just now, the high-end instruments yang I mentioned is your X-ray crystallography, X-ray analysis ataupun NMR. Because to handle this instrument, dia perlu background knowledge yang very strong, fundamental knowledge dalam chemistry, dalam science, a very good fundamental knowledge. So you kena tahu, you tak boleh macam just macam robot kena ikut satu pathway, no. Jadi kalau katakan ada compound you mungkin slightly different, apa command nak guna, apa solvent nak guna. Okay. Other than that, you can also become an educator. Okay. Educator, that means kita sekarang ni nak menggalakkan student-student generasi muda untuk lebih berminat ke arah STEM, ke arah sains dan teknologi. So it's very challenging nowadays to encourage the youngsters to have more interest in science and technologies. Okay, lastly we have engineers and also data analysts. Okay, sebab sekarang ni dah banyak guna computational. Examples in my studies area pun dah ada analysis using DFT, ada homolumo and so on. So this will becomes a very good data punya library so that other people can always refer to that structure. So you can also become a data analyst. Okay, meet the team. So this is my team member, my students basically. So we work hard, we do research hard, we enjoy hard as well. Okay. So budak-budak sains ni don't worry, dia bukannya nerd, dia bukannya dalam lab saja. So we do go out and play, we go to conferences, we enjoy masa team building, we enjoy ourselves. Okay. Right. Kita ada Q&A session. Before that, kita nak announce pemenang ke? Atau Q&A? Alright, kita jawab dulu soalan. Doctor, why are E-means brightly coloured? Okay, very good questions actually. Okay, E-mean actually does not have colour. E-mean is colourless. But when you bond with your transition metals, kalau you tengok periodic tables, you ada kumpulan 1, kumpulan 2, logam peralihan. Okay, baca peralihan, that means your transition metals, especially the first row. Scandium, titanium, vanadium, copper, chromium. Okay, so compound ni, metal ni yang coloured. So kalau dia ada bonded dengan copper, dia akan jadi biru. Kalau dia bonded dengan cobalt, cobalt is very nice deep red, ruby color. Okay, so that's why when you bond this ligand, this She base with metal, so it will produce very colorful compound. Okay, ada soalan lain ke? Okay, other than that, imine ni kalau you bond dengan transition metals, rasa special buat transition metals ia d orbital. D orbital ni is partially filled with electron. So kalau you observe dalam UV, this electron will excite to higher level. Okay, the excitations of electron tu dia akan produce different color. Kalau okay, another example of colored different material is your iron 2, Fe2 dengan Fe3. Fe3 kita tahu dia dah oxidize color karat, color brownish red, okay. Tapi kalau dia color asal metal, it will becomes, iron 2 will becomes a very nice fluorescent green color. Right. Ada lagi soalan ke daripada penonton? Okay, selain daripada imine, apa lagi ligand-ligand that we have? We can actually have thiocarbamate, thiourea, thiosulfate, thiocarbazite. Bila cakap pasal thio, that means ada S, sulfur. So, imine is C double bond N, only have nitrogen. Tapi bila ada thio, that means you have C double bond S, O. Okay, so nitrogen, sulfur is a very good donor atom. Kalau tengok dalam kumpulan periodic table, you will have nitrogen group 15, sebelah nitrogen is your sulfur group 16. That means nitrogen, oxygen and sulfur. These three is a very good donor atoms and have potentials to have to coordinate with metal. Right? So, kita nak umumkan pemenang untuk soalan kuis. Tahniah dan syabas saya nak ucapkan kepada pemenang pertama kita. Okey, Cik Alia Najwa binti Ismail. Tahniah Alia. Kita ada pemenang kedua. Pemenang kedua Nur Anis Syahidah binti Ismail. Tahniah Cik Nur Anis Syahidah. Dan pemenang ketiga kita ada Cik Nur Farhanis binti Faisal. Okay, we have 3 ladies here for today's night. Okay, terima kasih kepada penganjur. Terima kasih atas jemputan. Saya harap semua pendengar, semua penonton dapat manfaat apa yang saya kongsikan hari ini. Kalau ada salah dan silap, saya mohon maaf. Dan kalau ada siapa yang berminat, boleh come and join us in iOS. Saya serahkan kembali pada pihak penganjur. Terima kasih.
Okay, baiklah, majlis merakapkan jutaan terima kasih kepada speaker jemputan kita pada malam ini, Prof. Madia Dr. Karimah Kasim atas perkongsian yang menarik berkaitan dengan kecantikan imine sebentar tadi. Jadi saya harap para hadirin dapat mengambil input-input yang berguna dan bermanfaat daripada perkongsian pada malam ini. Tahniah juga saya ucapkan kepada para pemenang prakuis, postkuis dan juga pemenang cabutan bertuah. Kepada yang menang, anda jangan risau, pihak kami akan hubungi anda dan pastikan hadiah yang disediakan akan sampai kepada anda. Untuk yang tak bertuah, anda jangan sedih-sedih kerana kita masih ada siri seterusnya pada 2 minggu hadapan dan anda masih berpeluang untuk menjadi pemenang nanti. Selain itu, kami juga ada menyediakan E-sijil untuk anda semua yang hadir dalam program pada malam ini. Jadi suka untuk saya ingatkan sekali lagi kepada hadirin hadirat yang masih belum mengisi Google Form kehadiran, anda boleh klik pada pautan kehadiran yang telah dipinkan di ruangan komen Facebook ataupun YouTube bagi mendapatkan E-sijil anda dan pastikan segala maklumat diisi dengan tepat untuk memudahkan proses penghantaran E-sijil. Jadi sebelum kita bersurai, saya Nazrin Alia selaku moderator anda pada malam ini mewakili Ahli Jawatan Kuasa Program Eksplorasi Instrumen STEM siri ke-37 merakamkan setinggi-tinggi ucapan terima kasih buat semua pihak yang terlibat sama ada secara langsung ataupun tidak langsung dalam memastikan program pada malam ini berjalan dengan lancar. Mohon maaf daripada saya andai ada tersalah kata, tersilap bicara sepanjang mengenalikan program pada malam ini, kerana yang baik itu datangnya daripada Allah Subhanahu Wa Taala dan segala kekurangan itu datangnya daripada kelemahan diri saya sendiri. Akhir kata, semoga kita berjumpa lagi dalam program seterusnya pada siri ke-38 iaitu pada hari, waktu dan platform yang sama iaitu Jumaat 25 November 8 hingga 9 malam di live Facebook dan YouTube FSM UPSI. Sekian wabillahi taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh. Terima kasih dan selamat malam. Bye-bye.
Terima kasih.
Ibu kandung suruh budiman, oh budi malam gelap, dengan budi penyebar tekad, pancaran semangat wajah. Ibu kandung suruh budiman, ibu pujaan kami, yang berjasa pada masyarakat, hidup gagah berani. Ibu kandung suruh budiman, dengarlah sumpah sumbang sinan suci. Selagi hayat di kandung badan, kami